Example 4, graphs that approach infinity. The question says, use the graph of f of x equals x cubed minus x squared minus 4x plus 4 to describe its end behavior. And we need to support the conjecture numerically. So what will we do? First of all, I will use the graph. Let's look at the graph. The end behavior means as x approaches infinity, what is happening to y? And as x approaches negative infinity, what is happening to y? So let's see. As I go towards infinity, what happens to y? Y looks like y is up forever. So it looks like as x approaches infinity, y approaches positive infinity as well, right? And as I go to the left side forever, this graph will keep going down forever. My answer is the y. My answer is what is happening to the y. The y is going down forever towards negative infinity, right? So we come to analyzing graphically or analyzing the graph. In the graph of f of x, it appears that the limit as x approaches negative infinity, as x goes to the left forever, f of x was going down forever, so we express that with negative infinity, and the limit as x approaches infinity, y was going upwards forever, so this is infinity. So your answers are basically the y. What is happening to the y as x approaches right forever or left forever? So to support numerically, we are going to use our function to substitute in all the x's. How will we support numerically? Construct a table of values to investigate function values as absolute value of x increases. That is, investigate the values of f of x as the values of x becomes greater and greater, or more negative and more negative. What do we do here? We are going to try numbers. For example, I'm going to put 0 in the middle and see what is happening. X is increasing infinitely here. I chose 100 and 1000 and 10,000. This is my choice. And I want to see what is happening as x goes towards negative infinity. What numbers should we choose towards negative infinity? I'm going to choose negative 100, negative 1000, negative 10,000. What will I do with these numbers? I need to know their y's. How do I know them? By substituting x here and here and here, right? And using your calculator, you will find out when you substitute 100, the number is 1 million. And you substitute 1000, the number becomes 10 to the power of 9. When you substitute 10,000, the number becomes 10 to the power of 12. So what are you expecting, or what are you seeing is happening to y as x approaches infinity? Looks like it's also increasing towards infinity. It's increasing forever, and you can try more numbers. But when I went to the negative infinity, I decreased the x from negative 100 to negative 1000 to negative 10,000. I found out that the answers became negative 10 to the power of 6 and negative 10 to the power of 9 and negative 10 to the power of, this is a mistake, 12. So the numbers are decreasing and decreasing forever. Can I catch a specific number that they will stop at? No. So I think what we did, or what our analyzing from the graph was right. As x approaches infinity, f of x approaches infinity. Here's this part. And as x approaches negative infinity, y, or f of x, was also approaching negative infinity. So yeah, probably we are right. Now, the pattern of output suggests that as x approaches negative infinity, f of x approaches negative infinity, and as x approaches infinity, also f of x approaches infinity. So the answer in the end must be written this way. The lim, or the limit, as x approaches negative infinity of f of x equals negative infinity, and the limit as x approaches infinity of f of x f of x equals infinity. I hope I made it clear for you. Here's a guided practice for you. Example number 4. Use the graph of f of x equals x cubed plus x squared minus 2x plus 1 to describe its end behavior, and we need to support the conjecture numerically. Okay? So you will do the numerically part. I will explain the graphing part. Okay? So first of all, I need to see what is happening to y as x goes towards infinity and what happens as x goes towards negative infinity, right? So the first part, the limit as x approaches infinity looks like y is approaching infinity, right? And the limit as x approaches negative infinity, what is happening to y? As I go to the left, y is going downwards forever. Train your eyes to look properly. I need to see as I go to the right, what is happening to y? So y is going upwards forever. As I go to the left, what is happening to y? Y is going downwards forever. So looks like answer A is right. As I go towards x, the limit of x towards negative infinity is the limit as x approaches negative infinity of f of x is negative infinity, and the limit as x approaches infinity of f of x is infinity. How will you support that numerically? As we did in the previous question, you can add 0 in the middle. And what numbers will we choose towards infinity? We started with 100, remember? And then 1000. And then we went to 10,000, right? And the negative ones on the left side, and see what is happening to y. These are all x's. And here would be negative 100, for example. 2, 3 numbers are enough. Negative 100. And here's, for example, negative 1000. And you can add another number if you wish. If it's not clear enough for you, you will need to add 3 numbers on the left and 3 numbers on the right. And then see, these are the x's, and then check what is happening to y. You will see that this y is increasing forever, so it's reaching infinity, and you will see that this y is decreasing forever, so it's approaching negative infinity. Maybe complete the table and try to relate why is your answer graphically true. Example 5 says graphs that approach a specific value. Use the graph of f of x to describe its end behavior. Support the conjecture again numerically. So what will we do? We will look as x approaches infinity and as x approaches negative infinity. Do you think the middle part of the graph is I should concern about the middle part? I should have a concern what is happening here. Should I look here? No, I'm looking towards the right forever. What is happening to the graph? Towards the left forever. What is happening to the y? So I don't care about this one. Don't look and just tell me they're going towards negative infinity, because I basically do not care about this part at all. This is not where the graph ends. This is a piece in the middle of the graph. So what do you think? As x approaches infinity, y is approaching what? What do you think? You think it's approaching 0? You think it is approaching 0 or no? And the negative infinity, what do you think? Let's see. So analyzing the graph, in the graph of f of x, it appears that the limit as x approaches negative infinity, or as x goes to the left forever, it looks like f of x is equal to 0, as you saw, and the limit as x approaches infinity means x towards the right forever. F of x looked also that it's trying to approach 0, and we can support that numerically. This is our function. We are going to substitute in these 3 x's. First of all, I'm going to try numbers towards as x approaches infinity, which are 100, 1000, and 10,000, for example. And as x approaches negative infinity, which are -100, -1000, and -10,000. Substitute in all the x's, don't forget, and use your calculator properly. You will get these answers. So what do you think? As x approaches infinity forever, what is happening to y? This means 0.3 zeros and then the 1. Okay, this is 10 to the power of -4. So what do you think? Do you think it's trying to approach 0? It's getting smaller and smaller and smaller towards 0. Yeah, it looks like that. And here it's -0.001 and then -0.001 and then negative what? 0.3 zeros again, 1, and it looks that this number is also getting smaller and smaller and looks like it's trying to approach. The more I go to the left side, the more it's trying to approach 0. So our graph analyzing was right that the limit is equal to 0. As x approaches negative infinity, f of x approaches 0, and as x approaches infinity, f of x approaches 0, and this supports our conjecture. This is the final answer. Limit as x approaches negative infinity of f of x is equal to 0, and the limit as x approaches infinity of f of x is equal to 0. And here, this example, I was approaching a specific value and not just infinity or negative infinity. Here's a guided practice for you to try. The question says use the graph of f of x to describe its end behavior and support your conjecture numerically. You should have a paper and a pencil and try with your hands the table. The graph looks like, as I go towards, as x approaches infinity, what is happening to y, and as x approaches negative infinity, what is happening to y. Looks like it's approaching a specific line over here. I don't know what is this line. I am not really certain about the line, but it's a line that is y equal to something. It's so inclined from me, but y equals to what? What do you think? I think I went so it's super inclined. Okay, it should be a little bit more down. It's less than half. It's something or a little bit more than half, right? No, a little bit above the half, because if I go straight from here, I might think it's a little bit more than half. So maybe 0.6. How will we know the number exactly? We will only know the number exactly by using the table as we did in the previous questions. Try the table and see, you will see that the left side, as you go to the left forever, it looks like it's trying to approach 0.6666. And as you go to the right side forever, you will also find that the numbers are trying to approach 0.666. And use, as we did, 100, 1000, 10,000, -100, -1000, -10,000. And this will show you that C is the right answer.